Hello friends, this video on chemical bonding part 31 is brought to you by examfear.com. No more fear from exam. Before watching the video, please make sure you have watched part 1 to part 30.
Let's talk about hydrogen bond. Hydrogen bond is nothing but attractive force which binds hydrogen atom of one molecule with electronegative atom. And when I say electronegative atom, I mean 3 atoms. It should be either fluorine, oxygen or nitrogen. Example, you have this HF. Fluorine is highly electronegative. It will develop a partial negative charge here. Hydrogen is electropositive. It will generate a partial positive charge because fluorine will attract electron towards itself. So, and then what will happen is, this is my HF. Now this hydrogen, since it has slightly positive charge, it will be binded with the next fluorine atoms. This is called hydrogen bond. We will study hydrogen bond in more detail in the next chapter, where we'll study we'll study this van der Waals force. It's the type of van der Waals force actually which binds to molecules. Right? So here if you see, hydrogen bond acts as a bridge between 2 atoms. There are 2 atoms. These are 2 atoms and they are hold, and this is a hydrogen bond as a bridge. Why we have hydrogen bond? So molecules that contains a highly electronegative atom linked to a hydrogen atom. In that case, we have a hydrogen bond. And the size of the electronegative atoms will be very small. So that's why only fluorine, nitrogen and oxygen can form hydrogen bond, because they are electronegative plus their size is small. So please note, only fluorine, nitrogen and oxygen forms hydrogen bond with a molecule in a molecule which has hydrogen atom and one of these atoms, fluorine, nitrogen and oxygen. There are 2 types of hydrogen bond, intermolecular and intramolecular. So if you want to understand the difference, let's understand the word internet and intranet. So when you talk about internet and you talk about intranet, when you say internet, everything you can see in the net, right? You can see in the website. But when I talk about intranet, it is the local website in your campus. So in your school or in your college, there must be intranet where you have some local websites for your school which you can open only in your school system. That is intranet. That means it's local. And when we talk about internet, it is global, right? Similarly, we have intermolecular and intramolecular hydrogen bond. Correct? So when you say intermolecular hydrogen bond, that means you are talking about 2 different molecules. Right? For example, in this case, HF, again there is one more HF here. Fluorine will get a partial negative charge, this guy will get a partial positive charge, and there will be bond between them. Right? Water also has same thing. H2O, slightly positive, slightly negative. Again, there will be one more water molecule somewhere here. So this will have slightly negative charge here, and it will be attracted here towards this. Correct? Similarly, one more water molecule, let's suppose you have slightly positive, slightly negative. This guy will get attracted. And these are the hydrogen bonds, right? So it's intermolecular. That means you have 2 different molecules and there's a bond. When you talk about intramolecular hydrogen bond, that means it is local, it is within the same molecule, right? That means if you see, when hydrogen atom is in between 2 electronegative atoms, fluorine, oxygen, nitrogen, in the same molecule. For example, if you see in this case, there is a hydrogen here, there is oxygen here, and there is a bond between them, right? This is called intramolecular. This is local. This is local actually within the same molecule. When you talk about intermolecular, you talk about 2 different molecules. So till now we have studied 2 kind of bond, covalent bond and hydrogen bond. Let's study the difference between hydrogen bond and covalent so that there should not be any doubt. When we talk about hydrogen bond, it involves dipole-dipole interaction. We'll study more about this when we talk about van der Waals force in the next chapter. When we talk about covalent bond, it involves sharing of electrons, right? For example, in this case, I have HF. There is a dipole created, negative here, so plus here. The more HF you have, it has negative here, it's plus here. There's a bond between them. That's called hydrogen bond. For covalent bond is a sharing of electron, right? Hydrogen bond is formed between hydrogen atoms and fluorine, oxygen and nitrogen. But covalent bond is formed between two electronegative atoms, both of which are not willing to give electrons. They will share the electron. Hydrogen bond is a very weak bond and covalent bond is stronger than hydrogen bond. So the effects of hydrogen bond, it has some effects. That's why we are reading it. We are studying this bond. The high melting and boiling point. Molecules have high melting and boiling point if they have hydrogen bond. For example, water is liquid because it has hydrogen bond. But H2S, H2SE, these are all gases, similar structure. But this is liquid. Why? Because of the hydrogen bond. Hydrogen bonds are soluble, covalent. Example, water. They are less volatile because there's a bond which is holding them. They have higher viscosity and high surface tension because somebody is bringing the molecules together, because they are all molecules, water molecule, let's suppose, and there is some force which is binding them up, right? So that's why they have higher viscosity and high surface tension. And if you see the expansion of water on freezing, this can be explained by hydrogen bond. See, in normal case, there are so many water molecules and they are attracted by hydrogen bond, so they are more dense, it occupies less space. But the moment you freeze it, it becomes ice. This hydrogen bond becomes weaker because it takes the crystalline shape, and this hydrogen bond becomes weaker, so it expands. Hope you understand this. In this water, the hydrogen bond is little strong. It binds the water molecule together, and it is in liquid form. It is dense and occupies less space. But the moment you freeze it, the hydrogen bond becomes weaker. It forms the crystalline structure and expands because the hydrogen bond is weaker there. Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.